Hello, I'm Param Singh. Hope you guys are doing well. In this session, we are going to design a function that reverses a given list. So, to kick this off, I've already written some test cases that our function design is expected to meet and pass. So, let's see what those are. So, our function name is list reverse. If it takes an empty list, it produces the empty list because there is nothing to reverse. If it is a one element list, the reversed list is the same as an input list. And then if there are two or more elements, those elements are reversed. So 1, 3 will produce 3, 1. And similarly, A, C, B, D will produce a list of D, B, C, A, and so on and so forth. So let's go back to our implementation file. We're going to start with the spec, and our function name is reverse list, and what it is going to take as an input. We know that it's going to take a list as an input, but what are the values? What are the types of the values inside this list? So if you think about it, we did not really specify what type, and our test cases are also indicating that it can take any type. So in this third example, we have integers. In the fourth example, we had strings. So what that means is we can't write here an integer or string dot t, and because the type could be any type. So instead we are going to use a type variable, which basically is any letter that you can type. So it typical convention is to go with a letter T, and it also produces a list of the same type T. And to indicate that it is the same type T, we have to say when T is a variable. So T is a type variable. So that's how we define type variables. Just to give you another example, let's say we have a function f, and it takes a tuple of type A and B, and let's say it reverses a tuple. So it produces an output tuple of type B and A, and then we have to say when A is a variable, comma B is also a variable. So this indicates that a function contains two distinct types A and B. It's going to take a tuple of A and B, but it is going to produce a tuple of type B and A. And that's how you define type variables. So going back to our reverse list, let's write our purpose. That's going to be simple reverses a given list. The third step is going to be the stub. So we start with def reverse list, and we can give it any parameter name. So list is good, and what it should produce. So the purpose of stub is to make sure we can run our tests, and here the signature is saying it can be a list of any type. So let's produce a list of one element 0, and that matches with the expected type. So now we are able to run our tests. So let's go back to our console, and we are going to run mix test, and it says undefined function error, my list reverse is undefined. Oh, Let's go back and reverse list. Oh, we had a list reverse as the name, and here we have a reverse list. So let's do it as list reverse, right? And do the same thing here. Save our file and then go back to running the mix test. And now our tests are running. Of course, they are failing because we don't have any implementation yet. And that's okay. The fact that our tests are able to run is all we are worried about at the moment. Now we can go back to our implementation and write down the implementation steps. So if you recall that it is a recursive function, and it is a recursive function because the input is a list, and list is a well-formed self-reference. So we need two cases. One is we need the empty list case, and let's see what we are going to do with that, but we don't worry about the implementation yet. We must first write the second case, which is the non-empty list, where we'll pattern match with head and tail, and we'll tease out the two pieces that we have to work with. So one is the head, and second is list reverse chord on the tail. So these are the two pieces we have to work with. Now we go back to the first case, which is the non-recursive case, or the base case, if you will, and see what we want to do. So when the list is empty, this is indicated with our test here that we want to produce an empty list. So that is simple. We write an empty list and we are good to go. Now let's shift our focus on the non-empty list, and we say we have these two pieces. We have the head of the list, and then the second piece, which we call as the natural recursion list reverse tail. It has already done most of our job. So we're saying we already have a solution for the tail of the list, and now we also have the head. How do we combine these two pieces to get the final fully reversed list? So it turns out that Elixir has a append function for the list. Let's see how it works. So if I start IEX, there is an append function called plus plus. So if I have a list of 1 and 2 and I append it an element 3, it will give me a list of 3 elements. I can append a multi-element list and I will get a concatenated list, if you will. Note that even when there is a single element, we have to enclose it inside square brackets, because if we don't, we are not going to get the same list. So there is this join operator in the list. So I believe this is called a non-well-formed list or something like that. But the point to note here is that even when there is a single element, we must wrap it inside square brackets for the concatenation operator to work properly. All right, so once we have that, then all we need to do is take our reversed list and then concatenate the head to this, and that becomes our implementation. Let's verify that this implementation works, and if not, let's try to debug it. So we'll run our mix test again, and we're lucky in this case that all our tests pass. So there you have it, a first implementation of reversing a list. We're able to learn two specific things: how to use type variable inside function signatures, and the concatenation operator for the list, which can combine the two lists for you. Now, more experienced folks might point out and say that, okay, this implementation is not very efficient, and they would be right. But at this point, we don't have all the tools needed to improve our solution. But at a later time, we are going to redesign this function once we are at that point, and will motivate that problem with some of the other ideas about algorithms and data structures. So let's wait until that point, and then we'll revisit this solution again.